What does pulse oximeter measure? What does pulse oximeter measure? Anybody would like to answer? What is, yes, very good. Muskan has given the first correct answer. No, Basil has given. Basil, Akansha, and Muskan. Yes, very good. It's oxygen saturation. It's oxygen saturation. Very good, Basil. Okay, oxygen saturation. ठीक है? So, what is oxygen saturation? Just let me explain you. Now, this is hemoglobin which can bind to 4 molecules of oxygen. Right? The hemoglobin which can bind to 4 molecules of oxygen. Hmm? When all the 4 are bounded, this is 100% oxygen saturation, which we called as SpO2. 100% oxygen saturation. If it is 3, 75. If it is 2, 50%. If it is 1, 25%. Yes, Dr. Purvik, Anuradha, good. So that is 100% oxygen saturation, right? Now, how is oxygen transported in the blood? Please keep this table with you. This is very, very important table. See, you can see oxygen is around 0.29 ml per deciliter dissolved in blood, and in the combined form with hemoglobin it is 19.5, right? On the arterial side. On the venous side, 0.12 and 15. Carbon dioxide dissolved form 2.62 on the arterial side. Venous side 2.98 and 46 and 49. Then this is the arterial oxygen, 95% PO2 on the arterial blood and 40 CO2. Hemoglobin saturation is 97%. On the venous side, oxygen 40, carbon dioxide 46, and saturation is 75%. Right? So this is important actually. Now, if you look into the oxygen transport, the major form in which the oxygen is transported is in combination with hemoglobin. 97 to 98% of oxygen is in chemical combination with hemoglobin. Chemical combination with hemoglobin, okay? 97 to 98% of the oxygen is in chemical combination with hemoglobin. The remaining 2 to 3% is in the dissolved form. In the dissolved form. But what is important is that this chemical combination will show saturation. That means after 100%, you cannot bind more oxygen. But the dissolved form, it depends upon the partial pressure of oxygen. It depends on the partial pressure of oxygen. That means when you are giving oxygen at high barometric pressures, which is called as the hyperbaric oxygen. Hyperbaric oxygen, that is giving oxygen at high barometric pressures, 2 atmosphere, 3 atmosphere, you are going to increase the dissolved form of oxygen. Okay, you can increase the dissolved form of oxygen. Dissolved form of oxygen. Right? So whenever you hear the term hyperbaric oxygen, it is giving oxygens at high atmospheric pressures which cannot increase the bounded form, but it can increase the dissolved form. Okay, it can increase the dissolved form. Now, coming to the oxygen hemoglobin dissociation curve. It is an S-shaped, S-shaped, matlab sigmoid shape curve. Like this it is. Like this, a sigmoid shape curve. Okay, so this is the plateau part of the curve and this is the steep part of the curve. Okay, the plateau part of the curve and the steep part of the curve. What is the cause of this sigmoid shape? The cause is that the four oxygen molecules, okay, the four molecules of oxygen do not bind simultaneously. एक साथ नहीं bind करते हैं वो. Do not bind simultaneously. They show cooperative binding. Okay, they show cooperative binding. First molecule increases the affinity of second, which will increase the affinity of third, which will finally increase the affinity of fourth. Okay, so there is a changing affinity or there is a cooperative binding. So the fourth molecule binds most easily, right? It binds most easily. There is supposed to be a TR conversion. Okay, there is a TR conversion. मतलब द डीऑक्सी मॉलिक्यूल में जो ग्लोबिन होते हैं they are present in a very tense state and as oxygen binds it becomes relaxed. So this is called as from the tense to a relaxed conversion. From the tense to a relaxed conversion. Right? So this TR conversion is because of the cooperative binding and the binding of the first to second to third to fourth. And this is the cause of the S-shaped curve. Now, what is the cause of the plateau? What is the significance of the plateau? The plateau shows a saturation and it also shows a safety factor. I'll tell you what it is. Safety factor. And the steep portion is the portion which is going to shift left or right. That means it is going to take up oxygen or it is going to give the oxygen when needed. Right? Now see. Now, this table is very important where you see that when the partial pressure of oxygen is 60, When the partial pressure of oxygen is 60, the person's saturation is 90%. So when the partial pressure of oxygen is 60, the person's saturation is 90%. इतना होता है 90%. Now, even if you increase the partial pressure of oxygen from 60 to 110, the person's saturation will increase only from 90 to 100%, because there will be saturation. And even if you decrease the oxygen from 110 to 60, the person's saturation will decrease only 10%. So this is telling you about the safety factor. That means till your partial pressure of oxygen is 60. Till your partial pressure of oxygen is 60, there is total safety factor. Safety factor होता है. Okay, because there is going to be 90% saturation. और जब तक person saturation 90 है, तब तक you will never have hypoxia, you will never have hyperventilation. Till the partial pressure of oxygen is 60 mmHg, the person saturation will be 90. You will never have hypoxia. Okay, now there is another word which is called as P50. P50, that means this person saturation 50. This is around over here. P50. What is P50? So what is P50? It is that partial pressure of oxygen. It is that partial pressure of oxygen at which the person's saturation is 50%. So that comes to around 24 to 26 mmHg. 24 to 26 mmHg. That partial pressure of oxygen. Okay, so what is P50? It is that partial pressure of oxygen at which the person's saturation is 50%. That is 24 to 26 mmHg. Now we often speak of right shift and left shift. What is this right shift and left shift? So we'll just look over the graph first. This can come as an image based question also. So this is my right shift, okay, and left shift. Right shift and left shift. Okay, what do you mean by this now? This right shift and left shift. Okay, so right shift अगर आप ऐसे याद रखोगे, it will be at the level of tissues. It is going to be easy for you to understand if you understand like this. Okay, now right shift का मतलब होता है that there is a decrease in the affinity of oxygen and hemoglobin, or you can say that there is unloading of oxygen, or you can say that oxygen is given to tissues. right? Now just imagine, when will you need to give the oxygen to the tissues? When will you give? Obviously you will give oxygen to the tissues when they are undergoing metabolism, isn't it? When they are undergoing metabolism, when they are utilizing oxygen. And whenever the oxygen is used and there is metabolism, there is going to be increase in carbon dioxide, dpg, temperature, H plus. H plus increase can be written as acidosis or a decrease in pH. Now we can remember, right means more. Right means more. What more? Carbon dioxide, dpg, temperature, H plus, which will cause the shift of oxygen curve to the right. Right means more. So you can remember conditions. Conditions A, anemia, right shift. Acidosis, right shift. Altitude, which altitude? High altitude, right shift. Even pregnancy, even your exercise, right shift. Okay, so conditions which can cause right shift are AA. Right? So right shift will be, right means more, and right means you are giving it to the tissues. Okay. Now there is something which is called as the Bohr's effect or a Bohr effect. Remember, Bohr में क्या आता है? O. So it is related to the oxygen. It is related to oxygen. So what is that Bohr effect? The Bohr effect is that when carbon dioxide binds to oxygen, oh sorry, when it carbon dioxide binds to hemoglobin, it disassociates oxygen. It disassociates oxygen. That means there will be oxygen transport. So this is going to be at the level of tissue. It is going to be at the level of tissue. So what is Bohr effect? When carbon dioxide binds to hemoglobin, oxygen will be released. And this is on the side of the tissue. So it is Bohr's effect. Now what is left shift? Left shift is loading of oxygen to hemoglobin. यहाँ पर P50 will be increased. If you look into the graph, there will be increase in the P50, right side. Or there is decrease affinity of oxygen with hemoglobin. Or there is binding of oxygen with hemoglobin. Right? That means L is on the side of L, that is lungs. Left L means less. What less? Same factors. Carbon dioxide, temperature, dpg, H plus. This is alkalosis or increase in pH. ठीक है? So less. Now remember one thing very important. Carbon monoxide poisoning. also causes a left shift. Stored blood, fetal hemoglobin, they will also cause a left shift. Okay, left shift, because they do not leave oxygen, and therefore it assumes as if there is left shift. And DPG has no role in fetal hemoglobin. DPG has no role in fetal hemoglobin. What is the cause? Adult hemoglobin is alpha 2, gamma 2. But the, sorry, adult is alpha 2, beta 2. Alpha 2, beta 2. But the fetal is alpha 2, gamma 2. And the DPG, it can bind to beta and displace oxygen. Okay, it can bind to beta and it can displace oxygen, but it has no role with fetal hemoglobin because it has got no affinity for gamma chains. Okay, it has no affinity for gamma chains, and therefore there is no role of fetal hemoglobin in or there is no role of DPG in fetal hemoglobin. Androgens, growth hormone, exercise, these all will increase your DPG, and therefore they will all cause the right shift of the curve. Yes, very good, Akansha, very good. The fetal hemoglobin having gamma chains has got more affinity to oxygen. Yes. The placental circulation shows double Bohr effect. Okay, the placental circulation, it shows the double Bohr effect. Now come to your CO2 transport. Once you've done this, let me know. इतना पूरा हो जाएगा तो let me know. Right? हो गया इतना पूरा O2 transport? Yes. Akansha, very good for that lovely flower. Okay, the pink colored lovely flower. Very good. हो गया इतना सबका O2 transport, and can we start with CO2 transport once you have done? Okay, done. Okay. Now, how is carbon dioxide transported? Carbon dioxide transported. 70% is transported in the form of bicarbonates in RBC. And this is the major form of transport of CO2. 23% is in the form of carb amino compounds. Carb amino compounds. That means in combination with proteins. Okay, in combination with proteins. And 7% is in the dissolved form. Okay, 7% is in the dissolved form. So the major form of transport of CO2 is bicarbonates. Now यहाँ पर important is your chloride shift. So this is our RBC, dumbbell shaped RBC. And you will see that carbon dioxide can easily enter the cell. Okay, carbon dioxide can easily enter the cell, but carbon dioxide is also produced as a result of metabolism in the cell. This carbon dioxide will combine with water and form carbonic acid, H2CO3. This reaction is very rapid in the RBC because of the presence of the enzyme carbonic anhydrase. Okay, it is very rapid because of the presence of the enzyme carbonic anhydrase. Now, this H2CO3 will dissociate into H plus and bicarbonates. This H plus will bind with the hemoglobin. Because hemoglobin is a buffer. So it will take up the H plus. And the bicarbonates will be exchanged for chloride. The bicarbonates will be exchanged for chloride. So the chloride will move into the cell, and chloride is osmotically active, so water will also go in, and this is called as the chloride shift. And the cells are slightly swollen because of the water. The cells are slightly swollen. This is called as the hamburger phenomenon. Okay, so the chloride shift is seen on the side of the RBC. Sorry, on the side of the tissues, venous side. Now, as we saw the Bohr effect, there is Haldane effect that is associated with CO2 transport. The Bohr effect is on the tissues. The Haldane effect will be seen at the site of lungs. That is when oxygen will bind to hemoglobin. When oxygen when binds to hemoglobin, there is release of CO2. What happens when oxygen binds to hemoglobin? It becomes more acidic. It is more acidic and it is going to release the oxygen, carbon dioxide, and carbon dioxide will be released into the alveoli. That is Haldane effect. Right? So carbon dioxide transport, Haldane effect. Bohr transport, oxygen effect. Oxygen transport is Bohr effect. Yes. Are you done with this, everyone? हुआ इतना? हो गया? एंड बाकी लोग आफाट आकांक्षा? We just have a tea break. Okay, around 15 minutes. Just take a tea break around 15 minutes. I will leave you today by 6:15 or 6:30, not 7. I will leave you just before 7 today. Okay, so we can take class tomorrow. Zyada der tak we can take. So tomorrow and day after, 2 more classes I have. Aram se we will complete. Okay, just take a tea break. 20 minutes is suffice. 20 minutes. This is going to be the last break now. Iske baad I will end up the class. Last break. Okay? इसके बाद I'll end up the class.